So the break statement. The break statement will kick you out of a loop, whereas continue causes an immediate retry of the loop. Did we not already demonstrate that here? Yeah. So here we told it to count from 1 to 10, but then we decided, oh no, if it's equal to 6, we're going to bail out of it. So the break caused it to kick out of the for loop, jump to the next statement following the loop. So it would have counted 1, 2, 3, 4, 5. It would have printed 6, but then it would have said, that's it, I'm done. It would have broken out of it, and then it kept going down here. Now there's another statement that's similar called continue. Continue doesn't cause it to break out. Instead, it causes it to immediately reiterate, skipping the rest of the body. So in this case, we were counting from 1 to 10. But then in the middle of it, we said if x is equal to 5, continue. So if x did equal to 5, it did not do these next three things. It immediately reiterated. So it would have printed 1, just you wait, hit enter. 2, just you wait, hit enter. 3, just you wait, hit enter. 4, just you wait, hit enter. 5, well, it can't get down to here because if it's equal to 5, it immediately continues. So it comes back up here and then prints out 6. So for iteration 5 and only iteration 5, it would have skipped these messages. The next slide is a guessing game similar to our own. Can we go away? Why do you persist in opening that every time? All right. Next slide. Talking about random numbers, and we've done that. You want to generate a number between 1 and 6? Go for it. Random.rand.int. First number is the starting point. This second number is the end point, and it is inclusive. So this would not go from 1 to 5 like a range statement. It actually goes up to 6. A little bit of inconsistency. And since it's repeating this 10 times in a row, it's going to print out 2, 4, 6, 4, whatever. It's going to print out the random numbers. And they use the end parameter to stop it from going to the next line. Worth demonstrating again. I know we've done it before. So I believe this is lecture K. Make sure that's the truth. Yeah. So define main, parentheses in parentheses colon. And down here, we're going to have our if statement, if underscore underscore name, and then 2 more underscores. Underscore, make sure you get that space there. Some students have had a problem if you leave that space out, not going to work. If underscore underscore name underscore underscore equals equals quote double underscore main double underscore end quote colon, then call main. So that end parameter inside the print statement, let's just make a little for loop that's supposed to print from 1 to 10. So for x in range, I want it to go from 1 to 10, so I'm going to make it go 1, 11. If I leave off the third number, it assumes 1 by default, so I could just put it in a comma there, 1, 1 there. Not necessary. And I'm going to print parentheses x, comma, end equals quote, comma, end quote, end parentheses. Now it's not going to look perfect, it's just going to demonstrate. And what do I mean by not look perfect? Well, we need to go to the next line before we're done. So I'm going to print parentheses quote, done, end quote, end parentheses. We'll get rid of that. But what this is going to do is it's going to print out a series of numbers just like you were typing them, and it's not going to go to the next line until it exits the for loop. Because what end does is it tells it don't print out a new line, instead print out whatever that is. So we're going to see a whole bunch of numbers with commas after them. And there we go, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, done. It didn't go to the next line until it hit this print statement right here. Hope that makes sense. If I took out that end equals comma bit, it'd print them all in a vertical row, right? If you don't have to do this, but what would happen if I cut that out? I'll probably undo that, so like I said, don't do it. There, right? So the end parameter prevented it from going to the next line each time. And sometimes that's useful. Now I'm going to Control-Z and undo that. All right, one thing we haven't done that I want to illustrate doing is getting input and catching mistakes, catching errors. They type in a letter when they were supposed to type in a number. For that, we're going to use a special statement that we haven't seen yet if you haven't taken Python before, called try. And what that does is it sets up a test, or not even a test, but it marks a block of code where if an error occurs, if an exception occurs, it doesn't crash. Kind of like this. What if I did this? Try, colon, and here's a statement we know is going to crash. Num equals int parentheses quote x, or blah, 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 whatever, right? That's got to crash. There's no way that it can convert that to a number. And so we're going to put back tagged 1, so it's immediately underneath the try, except colon, print, oops, error caught, end quote, in parentheses. So it's not going to crash anymore, whereas it would have before. We could prove that to ourselves. Don't do this, but I'm going to prove it. I'm going to copy and paste that above the try statement, like that, and this is going to cause it to crash. So if I leave that in there, I'll never get the program to run, so that's why I'm going to comment it out or delete it. But when it runs, see, it blew up, because of course you cannot convert these numbers to a letter. The technical error is invalid literal. Okay, guess it's literally wrong. Literal just means it's literally typed into the program. So that'll never work. So I'm going to get rid of that statement as promised. But this is not going to crash it. Same code, but it's in a block of code marked between try and except. Now this kind of error is called an exception. It hits an exceptional state from which it cannot recover, and that's why it crashes with the red text. But what this means is go ahead and try it, but if that exceptional state occurs, I'm going to handle it instead, so I'm not going to let the program crash. Oops. So now when I let it run, it's not going to crash. It's going to print out that error message. Oops, error caught. We can use that to our advantage. We want them to enter a number, say a number between 1 and 10. If they type in something less than 1, we want to tell them that they made a mistake. If they type in a value greater than 10, we want to tell them that they made a mistake. And if they type in garbage, we want to tell them they made a mistake. So what we're going to do is whatever our input is supposed to be, age, score, I don't know, score equals 0, we need a value above our while loop.
Above our while loop?
Above our while loop.
Oh, okay.
That causes the while loop to trigger. So while the score is less than 0, or the score is greater than 10, because those are going to be the marks that, let's make it less than 1, my mistake, because we want to allow it to be 1 to 10. So while the score is less than 1 or the score is greater than 10, we're going to keep looping. And we set it equal to 0, so sure enough, it won't be, right, it'll trigger. Because if it's 0, it's less than 1. It'll come into this loop. Let's tell them what we want. Print, parentheses, quote, enter a number between 1 and 10. Heck, let's make it a whole number so it's even more likely to crash. Enter a whole number between 1 and 10. Now let's get our input. But we don't want it to crash. We don't want the input to be able to crash at all, so we're going to mark off the code with a try. So underneath that print statement, try, colon, and then score equals int, parentheses, input, parentheses, in parentheses, don't type that colon I just did. I backspaced it.
Empty parentheses just means input follows, right?
Right. It means don't print anything. But what I've been doing is putting that greater than sign there. That'd be just as good. Looks like eyebrows and a nose. You know, the Japanese write their smileys horizontally like that with all the special symbols available to them in our language, whereas the English write them like, like that. Anyways, empty. We don't even have to do that. I could just do that. Is that what I had originally?
Yes, sir.
Okay. All righty. And then we're going to catch the mistake. And if they did type in something that generated an error, we're going to print it, let them know.
Are we using except to catch them?
Oh, yeah, it is, because that's a Java statement, not a Python statement. Thank you. Except, colon. Print error must be a whole number, period, end quote, in parentheses. And then down here, we'll print some message to say that we're done with the loop, just to prove it, right? Parentheses, you entered, end quote, comma, score. Just to show that we're done, right? So what is this code? This is data entry loop. A loop that requires, can I spell correctly? That requires the user to enter a valid int between 1 and 10 and uses try except to handle crashes. And I could say that from now on, I don't want you to write any programs that'll crash. And so you should always use try and except. Now, I'm not going to say that, but if you do write your code like that, if you do write your code that loops and you have a try except in it, more power to you. You're becoming more of a professional programmer. So, your choice. If you want to be more of a pro, go ahead and use try and except to catch the errors. You could just wind up probably copying and pasting this code or something like that. Your while condition will be true based on the input that you want to allow. Right? If it's supposed to be a test score between 0 and 100, you could rule out negative numbers or numbers greater than 100. I'm going to run it and see if I got a syntax error or anything like that. Enter a whole number between 1 and 10. All right, I'm going to be rebellious and not enter a number. Error must be a whole number. Okay, well, I'll give in, but I'm going to type in a negative number. Negative 9. Well, what if it's an 11? Nope, 10. All right, okay, so that actually did work. We used try and except to handle crashes so that it won't crash if they type in something invalid. And since I was trying to convert it to an INT, even a decimal point will cause it to be invalid. Right? If they type in 1.1, must be a whole number. Not the way computers are, you know. It doesn't know that 1.0 is a valid. I mean, that's not an int, even though it's an int in our brain. It's a whole number. It's not. It's still got a fractional component. It's just that the fractional component is a 0. So it'll tell me. Enter a whole number. I could say a number without a decimal point, right? Something like that. Okay. I do want you to remember what try and except are, even though there's no quiz questions over it in MindTap. I want you to know what try and except does.
So basically, try if you are successful, it just does the statement underneath try.
Right.
But if
it's kind of like this was an error, right? If error.
Okay.
But
then
exactly.
It tells you to do that. All right.
Yeah. And so if there is no error, it'll jump down and not do this line. Just like this was written, like, you know, if error. That's not going to work, right? We don't have any error defined, but that's the way it works. Try this, and if there's an error, do that. If there's not an error, don't do it, right? Then we're at the bottom of the loop. All right, I'm going to undo that, and I'm going to add a comment here. because I want us to get into the habit end while. Line that one up with the while statement. While, end while. It just makes the code more readable. So the observation is, and it's a very good one, that if they type in a number that's out of range, we don't tell them what's wrong, right? We don't say no, incorrect size. So I guess we could throw an if statement in, right? Lined up underneath this except, or how about here? I think that'd be a good place for it right there.
An if statement?
Right, we're going to make sure that it's between 1 and 10, and if it's not, we're going to tell them that they entered it out of range. So I'm going to move my cursor here right after my input statement and do if score less than 1 or score greater than 10, colon, I'm going to print out an error message. Print number out of range. Please re-enter. End quote, in parentheses, like that. That'll just let them know. So that needed to be lined up with that score statement, so all of that is part of the body of the try loop. Now if this crashes right there, then it's not going to get here, and it's not going to print that. And that's perfect. We don't want it to print that if it crashes. If it crashes, instead it's going to jump down here. Thank you for commenting on that. So let's run it. All right, so if I type in 99, it's going to tell me what's wrong. That's a much better program, actually. Good. I'm happy about that. So this is the only code we added in order to handle that. All right, so random numbers we know how to do. We've done that now. You use import random, and then you use random.int and give a range. And here's their guessing game. Their guessing game lets you enter a smaller number and a larger number and pick the number between those. So when I'm about to play, I can say I want to guess a number between 1 and 2 million, right? Or I want a number between 50 and 57. I, the player, get to pick that. That's the only difference between their guessing game and ours. Their guessing game does have a counter. It's going to be printing 1. And keep track of how many, so that when you finally win, it says congratulations, you got it in count number of tries. But it doesn't put a limit on it. I like our guessing game better, because ours supports the idea, even if not completely implemented. One of the parts of your homework was assignment to make it have a limit to how many tries. And this isn't set up to do that, whereas ours was. And the reason that ours lets you add that is because we had an if statement down here at the very bottom, where if user number is equal to my number, we tell them great, you did it. Else we tell them sorry, you failed. And that way, if we break out of the loop for having too many tries, then we check. Did they get it right? Did they get it wrong? And we can print the message appropriately. So errors to rule out: incorrectly initialized loop control variable. If you don't initialize your loop control variable, it's not going to work. What do I mean by that? What if up here I decided to declare, what if I said it had to be a number between 0 and 10? Don't make this change, but what if I said it had to be a number between 0 and 10? And then I run it. Well, it didn't let me type in anything. And the reason why is I initialized this to a value that I shouldn't have. Why? Because 0 is now a valid value, so it doesn't enter the while loop. So, doesn't go into here. If I wanted it to work like that, I'd have to change it to something less than 0 or greater than 10. And then it would start looping again, right? Because now negative 10 is in fact less than 0, and so it would enter the loop. So if something funny is going on and it's not going into your while loop, look at your initialization. I'm going to change that back to the way it was, though, so I don't have to change all my messages. There, I just undid my 2 changes. So if a loop must be run at least once, use a WhileTrue loop with, quote, delayed examination of termination. Okay, so I think this is cool because most textbooks don't show WhileTrue. So some languages, and not this one, so don't type what I'm about to do, have this keyword called do. And the way it works, like I said, don't be typing this. Keep repeating this while x is equal to negative 1, or while x equals 1. So it does this before it does the test, right? Does the body first, then it does the test. Up here, everywhere else, we've done the test first and then the body. So that's what's called a pre-test loop. A do loop is what's called a post-test loop. The guy who invented Python didn't like post-test loops, so he didn't implement that at all. But he could have, but he didn't. And the reason he didn't is because you can simulate this with a while true and a break. What do I mean by that? While, parentheses, or not even parentheses, sorry, wrong language, capital T, while true, colon, let's do something. I don't know what, but let's do something. X equals int, parentheses, quote, enter a number or negative 999 to quit, end quote, in parentheses. Wait, I've goofed that up. What did I do wrong? That's totally messed up.
The while needs to be all the way back to the
While true.
Well, the true is okay, but I messed this up. I was trying to get
I'm just
input.
reading over. I'm sorry.
I'm turning in a stupid string into an int when that should be an input statement, right?
Yeah.
So how about we do it like this? I'm going to cut all that. Int parentheses input parentheses quote, and then have all that in there. So space space end quote in parentheses in parentheses. And I'm not going to mess with try and accept. I'm not going to be a professional programmer. I'm going to be lame. All right. But if they typed in negative 999, I want it to quit. So if x equals minus 999 colon break. Leave the loop. Else we can do something useful. Else colon print parentheses quote. Okay. Let's do something useful with end quote comma x. Whatever, right? We're not going to really do anything with it, but we could be adding it to the total. And so it's going to keep running until they type in a 999, a negative 999. So the body of the loop is always going to be executed at least once. Because since it says while true, that means run forever until a break statement is hit. So it's going to do that no matter what. And then it's going to check to see if it's supposed to bail out of the loop. And that's different than what we've been doing up here. Up here we always tested the condition at the top of the loop, and we didn't even go into the body if this condition was not true. Which is why it failed when I set this score to an invalid value. It didn't go into the while loop. If we had set it up more like this, it would go into the while loop no matter what. So we could rewrite this code so that we didn't have to initialize a variable before we got into it. I'm not gonna, because I think we already have the concept, and if I go and start making changes to it, then we're gonna have syntax errors and stuff like that. Let's run it and see. All right. Okay, so I'm going to type in some numbers, and then I'm going to type in -999. Whoops, where'd that 7 come from? -999. It did work for me, so let me come back there and see what it's doing for you.
Oh, wait, no.
But you raise a good point. I don't necessarily have to convert it to a number, and I could let them type in something better than 999 to quit. It's going to take a little bit of edit, guys, and I'm sorry about that. I'm going to make several changes. If you don't want to, for risk of breaking your code, you can leave it alone. But here's what I'm going to do. I'm going to take out the INT keyword. 1, 2, 3, 4 deletes. I'm going to remove the closing brace. And then instead of making them type in -999, I'm going to make them type in Q. Enter a number or Q to quit. So that's all the changes I just made to my input statement. I took out the INT and a closing parentheses, and then I changed my quit value. And so now I need to check to see if they typed that. So I'm going to rewrite this if statement. If x equals quote Q quote break. Else they gave us an integer, or at least they didn't type in a Q, and so we can use x equals int parentheses x. And so that's kind of nice, right? Letting them type in Q rather than forcing them to type in a weirdo number. That's the way humans think, right? You know, I want to type in a number, or I want to type in the word quit or a Q or something like that. So now I can keep typing in numbers until I'm ready to bail, and then I can type in a Q. And so all of my good code would be in this else. And honestly, I don't need the else here, because if it breaks, it's not going to get to this stuff anyways. So I could remove the else and then back tab everything after that one level. All right, I'm going to add a comment now, and then I'm going to walk about and make sure everybody's caught up. End while needs to be lined up under while. So let's make sure we stop about 10 minutes early so we can do that. Or I'll just start blathering about arrays even before you ask your questions. Anyways, let's go. To halt the loop that appears to hang during testing, type ControlC. All right, why would that happen? Suppose I wrote some silly little loop that went forever, like this. While true, colon, print, parentheses, quote, you've been hacked, end quote, in parentheses. It's just going to do that over and over and over once it gets to that point, because there's no way out of the loop. And this is telling me, whoops, wrong. PowerPoint's telling me that if they type in Control-C, it'll stop it. And that's true. Keyboard interrupt. Unless your input statement is inside a try catch, in which case it won't fail. Because this is an exception, just like trying to do an INT on invalid data. Obviously that's a bad idea, so I'm going to get rid of that. Control-C is an old thing. If you were using DOS programs or Unix programs during the 70s, you would have been typing Control-C to stop your program.
Excuse me.
Bless you. All right, so our summary. Control statements determine the order in which the other statements are executed. If statements, they're conditional. If do something, well, that something won't happen if the if is false. Or if you need something to happen over and over, you use a loop. If you need a definite loop, in other words, you're going to be processing through a range of values, a series of values, you use a for loop. Oh, while we're talking about it, let's create an array and then use a for loop to print through it. So in other languages, you have to specify the size of the array when you're starting. In Python, you don't. In Python, you just create an empty list and you start adding to it. But if you're using another language and you need to create an array, you have to allocate it to a certain length. something like this. I'm going to say array equals, and how long do I want my array to be? I want it just to be 5 elements long so I can hold 5 numbers in it. Array equals 5 asterisk square, that's a square, not a curly brace, 0 in curly brace. That says make a structure that's 5 long and every element in it is a 0. Now in the past we did it like this. I know we've talked about lists. You don't have to type this comment, but here's how we did that in the past. Right? That looks a little bit more familiar. They do the same thing, except this lets us specify the length. Well, who cares? I like doing it like this. Oh yeah? Well, what if this was 20,000? You would not want to type in 20,000 numbers separated by commas. I'm going to go back and make that a 5. And then I can store values in it. Array subscript 0 is equal to 1, 2, 3. And array subscript 1, and when I say subscript, I mean open square brace followed by a number and then a closing square brace equals 4, 5, 6. And let's print our array out now. Print parentheses array end parentheses. And now it's going to print out 1, 2, 3, comma, 4, 5, 6, comma, and then it's going to print out 3 zeros. Because the first element in it, the one at position 0, has been changed to 1, 2, 3. The second element in it, the one at position 1, is 4, 5, 6, and then the rest of them are untouched, so they all still equal 0. All right, it's getting tedious to enter all this data, so it's getting time to like make a main2 or something like that. And see, there's our array. 1, 2, 3, comma, 4, 5, 6, comma, and then the rest of it is still set to zeros. You can use a for loop to step through an array. Like this. For value, and that variable can be called anything. It's not important to call it value. For value in array, colon, print parentheses value. Or print parentheses quote value, can I type? Value is, end quote, comma value. And so now 1 per line, it's going to print value is 1, 2, 3, value is 4, 5, 6, value is 0, value is 0, value is 0. So you could step through an array just like you can a range. And we've done that. We've done that in prior assignments. We created a list of books or characters or something like that, and we stepped through it like that, or stepped through a phone number, right? 8675309, whatever. For Q, and there it is, right? There's our array printed out like that, and here's our array printed out with the for loop. What if we wanted the sum of that array? Total equals sum parentheses array in parentheses, and we could print that out, or divide it by 5 or something to get the average. All right, I think we've done this one long enough, right? Main is long enough. So let's def main2 parentheses in parentheses colon. Make sure that def is back tabbed completely against the margin. And then comment out that main call. Whoopsie. Where am I? Where's my keys? Right there. Comment out that call to main right there. And put in a call to main2. Now we'll be ready to do this, right? We won't have to enter data every single time we run it anymore. Instead, we're going to be calling the main2 function. But I do want to make sure that nobody has any syntax errors. But in order to test it, I at least have to have something in here, right? Print main2, end quote, in parentheses. That way I can test it to make sure it does that. Good, I don't have to do any data input now. At least not for, not until we add some more. So if you ever wanted it to do, the original behavior, you'd uncomment out that, right? I mean, we could make it even more sophisticated, like where we asked what we wanted to do to run main or main2 and then have an if statement to do it. That's a little bit much. Done with the PowerPoint. Let's go grab chapter 4. Now you'd think we were going slowly, but we have talked about a lot of stuff outside of the book as well. So I don't mind us going the rate at which we're going. All right, strings and text files. We've talked about strings a little bit. What's a text file? Well, we've been using text files the whole time, honestly. Text file is just a file with a series of typewritten characters in it. So like if I fired up Notepad and I typed in "this is awesome" and saved it, a .txt file is a text file. Also, idle creates text files. They don't end in .txt unless we tell it to. They end in .py, but it's still text. So, this is saying you will learn how to extract portions of a string called substrings. Well, we've already done that, but we called it slices. Like this. If you had name is equal to Robert, and then you just wanted the first 3 characters, you know, V is equal to name, subscript starting at character 0 and going 3. By the time that ran, it would equal Rob. What this means is start at position 0 and go up to but not including position 3. Or the way I like to think of it is you take the difference between the 2 values and you're going to start at 0 and it's going to be 3 minus 0 long. So you would get 0, 1, and 2. What if we did it like this? V is equal to name 1:4 end colon. Well, starting at position 1 and going up to but not including position 4, but I like to think of it as 4 minus 1 is 3. So starting at 1 and going 3 more. Well, what's position 1? It's at O, right? Because this is 0. So that's 1 and then go out 3. And so now it would equal OBE. They're calling that a substring, and that is the correct term. It's when you're dealing with arrays, with lists, that it's called a slice. But the same syntax is used for both, so sometimes I call both of them a slice. But strictly speaking, this is a substring because it gets part of this string. So the structure of a string. The first letter in the string, the first character in the string, doesn't have to be a letter, right? It could be a symbol like a question mark or a number, is position 0. The next one is position 1. The next one is position 2, and so on. So if we did this, under main 2, let's create a name variable. Put your favorite name, Edward. Don't know why that came into my mind. And then if you do print, parentheses, name, subscript 0, in parentheses, can I type? In subscript 0 in subscript in parentheses, it's going to print an E because that's position 0. In that case, the D would be position 1, that's position 2, the W, that's position 3, that's position 4, and that's position 5. So if I tell it also to print parentheses name subscript 5 in subscript in parentheses, I'm going to see it print a capital E and then a lowercase d. Let's prove that. Yep, it printed out the E and then it printed out the D. What if I change this string to something shorter than Edward? What if his name becomes Ed? Right? It's got a nickname now. Now it's going to crash. It says string index out of range. What index means out of range? You can use the terms index and subscript interchangeably. Well, if it's only 2 characters long, we can't go to position 5. I'm going to undo that change because I don't want it to crash like that. But I could rewrite the code to calculate the length of that and then use that length to get the last character out. So what is the length of that? Well, let's find out. That's a lowercase l, by the way. That's not a 1. Lowercase l equals len parentheses name in parentheses. And so if I do this, print parentheses quote length of name equals end quote comma l, and again that's a lowercase l and not a 1, it's going to print out 6 because this is 6 characters long. The available characters, the ones we are allowed to access, are 0 through 5. You can go up to the length minus 1. Right? If it was 10 characters long, you could access 0 through 9, because 0 through 9 really is 10. You could count them off on your fingers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I'd counted them on my fingers, that would be 10 fingers. So when I run, it's going to say the length of the name is 6. So if I wanted to print out the first character and the last character, here's what I would do. Print parentheses name subscript 0, because that's the first one, comma, and the name subscript, and I can use the len function to get the last position, but I'd have to subtract 1, right? Because if the length of it is 6, I can only go out to 5. So name subscript len parentheses name in parentheses minus 1 in subscript in parentheses. Sorry for the gobbledygook. That's a lot of typing, but I'm going to show you a fast and easier way of doing it in just a minute. Let me make sure it runs first before I brag too much about it. All right, and so it printed out ed. If I changed it, like to Jonathan, it'd print out the J and the N, right? This isn't an N because position 5 is not the end of the string anymore, right? What is position 5? 0, 1, 2, whoopsie, come back up here. 0, 1, 2, oh, what is your problem? Well, anyways, 1, 0, 1, 2, 3, 4, 5. Position 5 is that T. But the length of this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 9. And so length of name minus 1 is 8. So we're going to get the 8th value. Starting here, 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, that's a lot of typing though. That length name minus 1, there's a shortcut. If you want the last character, you don't have to calculate the name and subtract 1 from it. You can use subscript minus 1 and it gets you the last. So print parentheses name subscript minus 1. I have a stray subscript here. Sorry. Name open subscript -1. Close subscript, close parentheses, and it'll print out the last letter. So this is a shortcut for this. They do the exact same thing. This is easier to type, huh? -1 is the N, -2 is the A, -3 is the H, -4 is the T, and so on. And Python's the only language I've ever seen that allows negative subscripts. Kind of cool though. So if I run it again, it's going to print an N on its own line because that is the last character. Yeah. So a string is just a series of characters. It doesn't have to be anything in there as long as you have the quotes. This is also a string, right? S equals, that's an empty string. Doesn't have any data yet. What if we wanted to add some data to it? S plus equals hello, space, end quote. And then S plus equals name. And then print, parentheses S. It's going to print hello, comma, Jonathan, or whatever you have up here. And indeed it did. This is called concatenation. This made an empty string, and I'm going to add a comment here to that effect. Empty string. And this is called concatenate. Concatenate. Or concatenation. And this is more concatenation. Concatenation. Concatenate means just take one string and append it to another. S doesn't have any data in it. Well, after that statement, it sure does. It has the word hello. And after that statement, it has the word hello, Jonathan in it. And then when we print it out, that's what we see. So let's just get out the word John out of our name, if that's the name that you used. What is that position right there? What subscript? What subscript is that?
0.
Yeah, that's 0, and I want to go up to but not including the A, so what position is that?
4.
Correct. So if I do this, print parentheses name subscript, and I'm going to get that substring, that slice, starting at position 0 and going up to but not including 4. And then in square brace in parentheses. And it'll print out John. Hello, Jonathan. And then it prints out John. Did I do the assignment yet where, don't type this, I'm just asking a question, where you type in a string that's got a sentence there and then you spit out each word of the sentence using substrings? Have I done that one yet? I'm not seeing any big nodding heads. Okay.
It's something like that. It's like a song, I think.
Yeah, well,
Movie or something.
if we have done it, this one's going to be easy because you get to do it again. But I don't remember us talking about slicing that much as we're doing right now. So a subscript operator is useful when you want to use the position, as well as the characters in a string. Here they're setting up a subscript. They're setting up an index counter. So if we wanted to print out every letter in the name, we could do so using an index. For x in range, parentheses, starting at position 0 and ending before the length of the name. In parentheses, comma 1, another in parentheses. And again, if you're starting at 0, you don't have to put that there. And if you're adding 1 to it each time, you don't have to put that there. So I cluttered this up with extra values. I could remove that 0 comma, and I could remove that comma 1, and it would do the same thing. Cleaner syntax. So I'm going to print out x. Print out x. It's not going to do anything useful except print out some numbers, but we're going to see what those index numbers are. There we go. 0, 1, 2, 3, 4, 5, 6, 7, 8. Well, those are good index numbers. So why don't we print out the character at that position, right? So not only print x, but print out x, comma, name subscript x in subscript. And there we go, right? 1 per line. The first character is a J, the second character is an O, the last one's an N. And since the length of the string is 9, we can access elements 0 through 8. So this is using a for loop with an index. This is an index-based for loop. You could also use a value-based for loop, which is a simpler syntax, which we did up here. Make sure it's tabbed over. For value, let me bump this up so that those of y'all in the back of the room can still see it. For value in name, or I could say for character in name, colon, print that value in parentheses. And again, it's going to print out all the letters in the name. I like this syntax. If I only wanted to print the letters of the name and I didn't need to know their numbers, I'd go for this one. Right? That's a lot easier to type. I mean, it's not that much, right? But, you know, I don't have to use any subscripting at all. They're like that, right? Now, the only difference is that if you're using a value-based for loop, you don't have the index number, right? There's no numbers at all in this loop. But sometimes that's okay. Right? If you don't need the index numbers, if you don't need those 0, 1, 2, 3s, 4s, and 5s, go ahead and do a value-based for loop. But if you do need those numbers for whatever purposes, go ahead and use an index-based for loop. So this is a value-based for loop. And we've seen range-based for loops already. For value in range, parentheses 10, in parentheses colon, print the value. It's just going to print 0 through 9. Range-based for loop. Make sure that's not a syntax error. All right, and it's not. So it printed out the numbers 0 through 9 as expected. The book's not going to use these exact terms for the for loops, but I do want you to remember the idea of a range-based for loop, but I'm calling this an index loop because we're using that number as an index, but it's also a range-based for loop. It's one and the same. It's just that whatever number we're using as whatever number we get out of it, we're using as a subscript. So I'm calling it an index-based for loop. And then a value loop. The value is when you give a list or a string here and it steps through them. We've already done that in prior lectures. We created a list and we stepped through them one by one. Well, it also works with strings. Name is a string, and that'll step through it letter by letter.
So the value-based loop, it goes through each one in the list until it's
Until
done.
it hits the end of the list. Right.
So basically, if we put a letter of code at the bottom, until it comes up with that letter of code, it'll keep going through the loop until
Until it runs out of letters in the name. If I said for letter and name, print out the letter, it might be a little bit clearer. That's all it's doing, is it's stepping through the name letter by letter. Now, I'm going to remove this word value and make it something else because I don't like the word value appearing in two different loops. So I'm just going to make this say for x in range 10, print x. Right? Just so that there's some distinction between them. So note that an index-based loop is also a range-based loop, but the number is used as a subscript. If I can get away with it, I'll always use a value-based loop to step through a string or to step through a list. If it's just a series of numbers, 1, 2, 3, 4, 5, or 2, 4, 6, 8, 10, you're going to use range.
If you have two lists, one list is a list of numbers that are consecutive values, say 1 through 10, and then you have another list with random numbers. Is there a way you can take the first number of the first list and compare it to every value in the second list?
To see if it's in there or not?
Right.
Okay, good question, good question. What if you had something like this? I'm going to use capital L to mean list. L1 is equal to, and let's make a list of certain values. Just type in some numbers, who cares what they are? No, not that big though, right? 12, 45, 11, whatever, 8, 5, or whatever, some digits. Right? Doesn't matter which ones. And then we're going to make list 2. List 2 is going to have a few of these numbers. So list 2 is equal to, and let's be very picky about which ones. I want list 2 to have a 8 in it, and a 12, and a 15. Just some of the numbers that are in here. You could even have more numbers in it, but I want some of the numbers in list 2 to appear in this list, but not all of them. And now we're going to go through list 1 and we're going to find out if it's in list 2. A couple of ways of doing that. Do you want to do it with an index-based loop, or do you want to do it with a value-based loop? If you don't need the index number, I would use a value-based loop. I have 2 more
Honestly,
questions.
I like to see both.
Well, let's do one and then the other. Alrighty, so let's do a value-based loop first. For value in L1, colon, if value space in space L2, if that value can be found in L2, let's print a message. Print value, comma, is found in L2, end quote, in parentheses. So it's not going to print 12 is found in L2 because it's not. It's not going to print that 45 is. It's not going to print that 11 is. It's not going to print that 5 is. But 8 is in L2. So it's going to print 8 is found in L2. And it's going to do the same thing for 12 and 15. And we could tack on some silly numbers here, right? You know, it doesn't matter. Like that. It's never going to print anything about 200 or 1, 2, 3, 4 because those are not in my list 1. Run it, make sure it works as advertised. All right, so the 12 is found in L2, the 8 is found in L2, the 12 is found in L2, and the 15 is found in L2. If we wanted to throw in an else to show that it's not, we could do that. So lined up with the if statement, I'm putting an else, colon, print value, comma, quote, is not found in L2, end quote, in parentheses. To do the index-based loop, let's step through L2 and find out if it's inside L1. I think we're getting close to stopping, actually, because I want to give people time to type in the notes if they were trying to and are getting behind.
Okay.
So let's...
I mean, this works if you need to stop.
No, I don't. I want to do the index-based loop as well. So one more. For, and what do we want to call our index counter? Why not index? That's a snazzy name. For index in range, parentheses, length, parentheses. Now I'm going to check for L2 to find out if they're in L1. So instead of length of L1, I'm going to do length of L2. That's a capital L. L2, close parentheses, close parentheses. Let's get the value out so we can test it. Value equals L2 subscript index in subscript. Now we've got a character and we can just copy and paste these 4 lines and it'll work the same way. So I'm just going to grab those 4 lines and paste them underneath it and tab it over correctly. There. But no, I goofed it up. I'm going to make some more changes. I'm so sorry to change my mind on you. We're going to go whole hog and do it all. No, I am going to leave it like that, but I am going to retype it. So if value in L1 colon print parentheses quote or print parentheses value comma quote found in L1 end quote in parentheses. Now I need my else statement. Got a back tab, else colon, print parentheses value, comma, not found in L1, quote, parentheses. So we're stepping through list 2 now, but we're doing it by index. But since we were doing it by index, all we did is we copied that value, that element of the array, the list, into a variable so that the code looks almost exactly the same as here. Because otherwise I would have had to type in L2 subscript index in every place that it appeared. And I'll show you what that looks like, and then I'm going to undo it. L2 subscript index there, right? And then L subscript index there, and L subscript index. Yeah, that works, but I liked it the way it looked better like that. So I'm going to leave it like that. Let's run it and make sure no syntax errors. All right, and so now it's stepping through list 2. Finding if it's in list 1. And so it did in fact find that there's an 8. It did in fact find that there's a 12 and there's a 15, but there's no 200s in list 1, so it prints that. And there's no 1, 2, 3, 4 in list 1. And so those are the messages we got. And you can use that for hangman, right? Say we're looking for a secret word. Secret equals, hangman. And then they make a guess. Guess equals, quote, X. It's wrong, right? It's not correct. If guess in the secret word, print quote, and then you could do something with it, right? Print guess, comma, quote, found in the secret word, end quote, in parentheses. Else, you're going to increment an error, right? Because hangman, you only get 10 chances or whatever. So else, colon, print parentheses, guess, comma, not found in secret word. And that is, in fact, the message we're going to get, right? Because X is not found in hangman. But if we change this to an A or an H or a G or something, it would. So you can write a hangman game using this principle of using the word IN. Needs to be a little bit more sophisticated than that, and we're not going to do all of it right now. Same idea, though. Right? X is not in the secret word, but if I change that X to an H, it is. Right? H is in the secret word. All right. There is a Dropbox already created, so you can submit your lecture to it. We're going to need some homework. So you're going, no, we don't really need homework. Yeah, let's do some homework. Have your code look like this. S equals, this is a sentence. But feel free to put your own word in it. Your own words. Then, using slices, subscripts, print out each word. So what's the first word? The first word is this. So word 1 equals, quote, no quotes, S subscript starting at 0 and then going out 4 characters. So 0 plus 4 is 4, like that. That'll be the first word. You're going to wind up using a different sentence here because I'm giving you the entire answer to this one. Word 2 is equal to, well, what is that position? Well, that's 0, 1, 2, 3, 4, 5. That's position 5. So S subscript 5, and how long is that word? It's too long. So 5 plus 2 is 7. And so on. Word 3 equals, I want to start with that letter. Well, what position is that? 1, 2, 3, 4. No, starting at 0. 0, 1, 2, 3, 4, 5, 6, 7, 8. So starting at 8. And what's my ending value going to be? I'm starting there, and I want to go up to, but not including the next position. So if this is 8, then what's my next number going to be? 9, yeah. Or you just think I'm getting one character starting at 8. So 8 plus 1 is 9. And you know what? And if I took this comment out and I printed out word 1 and word 2 and word 3, it would print out this as a sentence. But use your own sentence, right?
The colon in there means that, like, it's like start to finish, right?
Right. Start and then go up to, but not including, just like a range.
Okay. Yeah.
Right. So 0, 4, 0, 1, 2, 3. So that's equal to the word this. And this is equal to the word is. And this is equal to the word a. But make your own sentence, not this is a sentence. At least 5 words. So, and then we would just print them out, right? We've printed out 3 words. I didn't put the 4th one in. I could do so pretty easily. What position is that? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's position 10. How long does it need to be? 1, 2, 3, 4, 5, 6, 7, 8. So 10 plus 8 is 18. So the 4th word is equal to the string starting at position 10 and going up to but not including 18. And then I could print those out, right? Print word 1, comma, word 2, comma, word 3, comma, word 4. Alright, there is a Dropbox, so feel free to upload your lecture when you're ready. And let's take a roll before you run out of here.